Marubini, are you there?
Yeah, I'm here.
How are you?
I'm okay.
Am I pronouncing your name properly?
It's Marubini, my boy.
Marubini. I must say it
Yeah.
quickly. Marubini.
Yeah.
Okay, Marubini, give us your question.
My question is that points A, -5 and -3. B, -1 and 2. And C, 9 and -6.
Yeah.
I've on a triangle ABC.
Of vertices of
Vertical.
triangle ABC.
Yeah. Calculate the gradient AB and BC and show that AB is 90 degrees.
I say calculate the gradient of AB, and you know that we denote gradient with a little m.
Yeah.
Okay, so we're going to calculate the gradient of AB and the gradient of
BC.
And hence
show that triangle ABC is 90 degrees.
Show that triangle ABC is right angled.
Yeah.
Okay. All right. So, Marubini, we start with the gradient questions, right?
Yeah.
Here they are. The gradient of AB and the gradient of BC. Correct?
Yeah.
Now we know that the gradient of AB, the formula is the y. You tell me.
It's y1 minus y2.
Over?
x1 minus x2.
Brilliant. Well done. But you see, here, that is absolutely correct. AB, gradient of AB, I like to write it like this. YA minus YB over XA minus XB. Because then I know that I'm going to take the y at A, and I know I'm going to take the y at B. Do you see? Because if I put ones and twos, sometimes I get confused, right?
Yeah.
Right. So the y at A is -3, and the y at B is 2. So it goes -3 minus 2, divided by the x at A, which is -5, minus the x at B, which is -1. But notice it's minus 1.
The positive one.
Good. So if I work that out, I get -3 minus 2, which is -5. And in the bottom, I've got -5 plus 1, which is -4. How are we doing so far?
It's good.
Easy, eh?
Yeah.
Okay. Next, the gradient of BC. We're going to take same formula. Correct? Same process. Do you agree?
Yeah.
Y at the one point minus the y at the other over the x at the one point minus the x at the other. Happy?
Yeah.
Okay. So the y at B is 2 minus the y at C is -6. So 2 minus -6, 2 plus 6.
It's positive 6.
And then x at B -1.
My x at B is B -1 minus plus 6.
X at B in the denominator, you must have x at B minus the x at 6. Yeah, boy. -1 minus 9. Now you get 2 plus 6 on top, which is 8, and in the bottom, minus 10. And we can simplify that further. And how do we simplify that further? We can see that 2, the number 2, goes into 8. How many times?
4 times.
4 times. And the number 2 goes into -10?
5 times.
Correct. You see?
Yeah.
So the one calculation gave us the answer of -5 over -4. And we know that minus over minus is?
Positive.
Right. And the other calculation gave us the answer of 4 over -5. Correct. It now says hence. Now when they say hence, Marubini, it means that what you have just done needs to aid you, needs to help you in answering the next part. Okay. So it says hence show to us that triangle ABC is right angled. Happy?
Yeah.
Okay. So what have I got here? I have worked out that the gradient of AB is
positive 5 over 4.
Good. And also, what did I work out? That the gradient of BC
equals to 4 over, minus 4 over 5.
Mm-hmm. Now, let's go and do a little bit of theory. If we have two lines that are perpendicular to one another,
Yeah.
what do we know about their gradients?
They form a right angle.
No, that's what you know. They form a right angle because they are perpendicular to each other. But
Yeah.
what do you know about their gradients? What does the theory tell us?
The reciprocal of 1 is minus 1.
Okay, so they tell us if you've got the gradient of, say, L1 and the gradient of L2, then
Yeah.
we know that because they are perpendicular, if we multiply these gradients together, we are going to get minus 1. So every time you take the one gradient of a line, you multiply it to the other gradient of the other line. If you get minus 1, you know that those two lines are cutting at 90 degrees.
Yeah.
Okay.
Yeah.
Now let's go back to your question. Your question says, find the gradient of AB and BC and hence show that the triangle is right angled. Now if that triangle is right angled,
Yeah.
then we know that somewhere, if we quickly try and draw a diagram, right? Let's try and draw a diagram. We had that A was minus 5, minus 3, somewhere there. We had that B was minus 1, 2, somewhere there. And we have that C is 9 minus 6, somewhere there. Correct. Now, if I join the lines, right?
Yeah.
It looks like maybe there's a 90 degree over there, in which case that triangle is then right angled. Do you see?
Yeah.
Now, which two lines are meeting at B? It is line.
It's A and C.
It's, careful, which two lines are meeting at B? It's line.
A, B, and CB.
There's no D. CB. Yes, correct.
I mean CB. There's no D.
So it's AB and CB.
Yeah.
There's no D here, right? AB and
Yeah.
CB. Okay, so now look, the gradient of AB is 5 over 4. The gradient of BC is minus 4 over 5. What do we get if we take those two gradients and multiply them together?
We get minus 1.
We get 5 over 4 times minus 4 over 5, which is minus 1. And therefore, triangle ABC is right angled at B. Do you see?
Yeah, I get it.
Now, the important thing here, Marubini, is the way you present your answer. You must understand that the question asks you to show that. So you cannot say MAB times MBC equals minus 1. You cannot write here equals minus 1. You must show that.
Okay.
So do you see how I represented my solution here? I said the gradient times the gradient equals, which equals minus 1. I mustn't put the minus 1 up there, hey? I mustn't assume that the product is minus 1. I must show that the product is minus 1. So you will lose marks if you do not show your calculation and present it correctly.
Okay.
Okay, Marubini, are you happy?
Yeah. Yeah, I'm happy.
Okay, good. Thanks, eh? Thanks for the question and keep on phoning us.
Okay.
Thanks, eh? That was Marubini and he's given us...
Thanks a lot.
Okay, thanks, Marubini. You can say goodbye.
Bye.
Bye.